So let's talk about how to graph the tangent function fairly quickly. Say you have to sketch tangent for an exam or a quiz problem. The way to do it is to use what we already know about sine and cosine. Tan x is equal to sine x over cosine x. So tangent can be thought of as this fraction. A fraction is equal to 0 when its numerator is equal to 0. The numerator here is sine x. So tangent will be 0 when sine x is equal to 0. That means the graph of tangent has x-intercepts where sine x is equal to 0. Now we need to be able to locate those vertical asymptotes for tangent. The vertical asymptotes occur at values of x where tangent is not defined. Tangent is not defined when the denominator is 0. And so vertical asymptotes occur where the denominator, cosine x, is equal to 0. So let's sketch a graph of tangent now, and I'm going to rely on what I already know about sine and cosine. So wherever sine is 0, 0, pi, 2 pi, 3 pi, negative 2 pi, and so on, that's where tangent will be 0. So let's go ahead and I'm going to just label pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So sine is 0 at 0, pi, 2 pi, 3 pi. So those x-intercepts for tangent are the same as the x-intercepts for the sine function. I'm going to draw vertical asymptotes wherever cosine x is equal to 0. So if I recall my cosine function, cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, and the negatives of those values. So wherever cosine is 0, pi over 2, for example, there's going to be a vertical asymptote for tangent. 3 pi over 2, 5 pi over 2, on and on and on. And in the negative direction, cosine is 0 at negative pi over 2, so tangent has a vertical asymptote, also at negative 3 pi over 2. Now, I need to be able to draw those curvy branches, and it probably helps to add points for pi over 4 and negative pi over 4. And I'm going to label my vertical axis with a 1 and negative 1. At pi over 4, tangent is 1. At negative pi over 4, it's negative 1. So that helps me see that the shape of the graph is increasing as I move to the right of 0. And the shape to the left of 0 is like so. And that pattern will repeat itself over and over. So I don't have to rethink, I just copy that pattern to the right and to the left. So to the right, I go on and on like so. To the left, say between negative 3 pi over 2 and negative pi over 2, from negative pi, I rise up and down this way. And again, I guess I've already drawn 1, 2, 3, 4. I have over 4 periods, so I'm going to stop here with that much of the graph because this pattern continues over and over again. So let's just summarize some important facts about the tangent function, the domain. The domain is a mess to describe because we want to say all values of x except where there are vertical asymptotes, but there are infinitely many. So how do we say that? We could say in words, all real numbers except where the vertical asymptotes occur. That's at x equals pi over 2 and negative pi over 2. So we could write plus or minus pi over 2. 3 pi over 2 and negative 3 pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, dot, 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 meaning with the pattern continuing on and on. If you want to describe the domain in interval notation, it's also a mess. Each interval represents a portion of the x-axis between two vertical asymptotes. So one interval would be from negative pi over 2 to pi over 2 in parentheses, union pi over 2 to 3 pi over 2, union 3 pi over 2 to 5 pi over 2, union, you just have to say dot, 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 on and on and on. Again, in the negative direction, you could write in front of this negative 3 pi over 2, comma, negative pi over 2, union with a dot, dot, dot in front also. So either in words, the first line, or the interval notation, which it really represents infinitely many of these intervals separated by the points where the x values where the vertical asymptotes occur. So the domain is a mess. The range is actually very simple for tangent. It's very different from sine and cosine. Every single y value occurs infinitely many times as a point on the graph. So the range is all real numbers. Or you could write the interval from minus infinity to infinity. The period of the tangent function is different from sine and cosine. So one period equals the distance between two of the vertical asymptotes, and that distance is always pi units over and over again. So the period is pi, not 2 pi, as is the case with sine and cosine. Tangent is an odd function. And that means if we turn the graph upside down, rotate it 180 degrees, the graph looks exactly the same upside down as it does right side up. Also, we can think of the odd function property as when we say that the tangent of minus the value of x is equal minus tangent of x. Tangent is not one-to-one. And tangent has no amplitude. So we don't even bring it up, but I just thought that's worth mentioning. It makes no sense to talk about the amplitude of tangent. So there it is, our graph of tangent based on the sine and cosine functions, really based on the zeros the x-intercepts of sine and cosine.